Good afternoon, everyone. Welcome to the Big Data Pilot Demo Day number 4, I-BiDaaS application to the telecommunication sector. I would like to give 1 to 2 minutes for people to join us, and then we can start. Here you can see today's speakers. So I hope you are all here. Let's start. Welcome to the Big Data Pilot Demo Day number 4, I-BiDaaS application to the telecommunication sector. My name is Despina Kopanaki. I'm project manager at Forth. Forth is coordinating the I-BiDaaS project. I would like to thank you for being here today with us. It is our great pleasure to demonstrate you the I-BiDaaS solution. Let's start. First of all, I would like to introduce you today's speakers. Dr. Dusan Jakovetic. Dusan is an assistant professor at the University of Novi Sad in Serbia, and he's also the I-BiDaaS scientific and technical manager. Today with us also is Dr. Ioannis Arapakis. Ioannis is a researcher at Telefonica in Spain. Telefonica is one of the I-BiDaaS data providers. So a quick overview of today's agenda. First of all, we have the pleasure to have today with us Marique Williams from Trust IT, representing Policy Cloud project. She's going to give an overview of the Big Data Pilot Demo Days, which is a joint effort between BigDataStack, I-BiDaaS, Track and Know, and Policy Cloud. Then Dusan will continue with a presentation of the I-BiDaaS project, an overview presentation. Ioannis will follow. He's going to describe the requirements for Telefonica, why they actually participate in I-BiDaaS. Then Dusan is going to present the scientific and technical view of the I-BiDaaS architecture and how it successfully addresses the requirement that Telefonica set. Then Ioannis will demonstrate the I-BiDaaS solution and its application to the telecommunication sector in a step-by-step fashion. At the end, we will open the floor for questions and answers. Let me say a few things here. First of all, you are all muted now. You will have the opportunity to post your questions in the Q&A panel. And at the end, our speakers will be more than happy to reply to all of your questions. You also have the opportunity to raise the hand. There is a button, and we will give the floor to you for a fruitful discussion. First of all, we would like to learn a few things about your background. Diego, may I kindly ask you to launch the poll?
Yes.
Thank you. For quick questions, let's have 1 to 2 minutes to reply. So the first question is about which stakeholder type do you belong? Let's give some time to people to start replying. The other question is if people are working with big data, if they are interested in big data technologies, and the main barrier or risk preventing from implementing big data analytic solutions. So people started.
Yes.
From what I can see. I see a lot of people from research and academia, 54%. Then we have big data technology providers, 14%. Great. Then, are you working with big data? 65% said yes, 33% no. And if you're interested in big data technologies to optimize your customer experience, 63% said yes.
So mostly yes.
Yes. The last question about the main barrier or risk preventing you for implementing big data analytical solutions in your organization. I can see lack of expertise, 53%, 21% it's costs, and 26% is uncertain value. Great, interesting. Diego, we still have
yes, 90% voted for now.
Mm-hmm. So most of the people are from research and academia or technology providers here today, and most of them are working with big data. So this information is helpful for Dusan and Ioannis.
Oh yeah.
We do have 37% saying that they are maybe interested in big data technology. So we do hope after this webinar to increase the percentage of those interested in big data technologies.
Sure.
Okay, so I think we can close the poll. Thank you very much, Diego.
Okay, I'm going to share the result with the audience, I think.
Mm-hmm. So, as said before, today with us, we have the pleasure to have Marie Williams from Trust IT. She is involved in the dissemination activities of Policy Cloud project, and she is going to give us an overview of the big data pilot demo days. Marie, the floor is yours.
Thank you, Despina. Thank you for the introduction and the invitation. So yes, I'm Marie Williams from Trust IT, and Trust IT leads the work package on communication dissemination in the Policy Cloud project. Policy Cloud develops a cloud for data-driven policy management. So when the Big Data Value PPP Summit 2020 was organized for May 2020, this obviously was in the middle of the COVID-19 crisis, or the very high moment. So at that point, the BDV PPP virtual summit went virtual. But this then also provided us with some opportunities to develop this series of big data pilot demo days, in which we would like to take you through this course. In the next slide, so here you can see why the big data pilot demo days. So the new data-driven industrial revolution highlights the need for big data technologies to unlock the potential in various application domains. So this is also why we have a series, why we are showing different applications in different domains. The BDV PPP projects, I-BiDaaS, BigDataStack, Track and Know, and Policy Cloud as well. They deliver innovative technologies to address the emerging needs of data operations and applications. And to exploit these technologies, the projects onboarded the pilots. So they differ from telecommunications, as we're looking in today, to retail, to shipping, to transport in other sectors, but also as in Policy Cloud to policy making. So in their third and final year, I-BiDaaS, BigDataStack, and Track and Know, they're ready to demonstrate the developed implemented technologies to interested end users or from industry, as well as the technology providers for further adoption, and obviously also research and academia, as many of you are in this call, to build upon that. So the recently started Policy Cloud project will highlight the adoption of the technologies developed by the more mature BDV PPP project, BigDataStack. And seamless analytical technologies and data skipping technologies for the policymaking sector. So in the next slide, thank you, Despina. So here we have a brief overview of what each project very briefly aims to do. So the Big Data Stack project will build a holistic stack for big data applications and operations. The I-BiDaaS project will build the industrial-driven big data as a self-service solution. Track and Know is all about big data for mobility tracking knowledge and the extraction in urban areas. And then Policy Cloud will build the cloud for data-driven policy management. So if you see, these projects are joining forces to showcase the application of innovative technologies in a variety of domains. So fostering further adoption and contributing this way to Europe's digital future. Despina, if you can have the, yeah, so here we see an overview of really what this full series looks like. So the first demonstration was about I-BiDaaS application to the financial sector. The next one for retail, the BigDataStack application for retail, and also a similar, so the BigDataStack solution for shipping was the third topic. Today we are in the fourth. What we would like to show with this is that there's a wide variety of big data applications to a wide variety of sectors. All the demos that have been done already are now available on each of the project's websites, as well as through the BDVA. So we really encourage you to consult these webinars if you haven't been able to attend them, because they're very useful material that you can use. Thank you, Despina.
Thank you, Marique, for being here today with us. Of course, we will have you at the end to say a few things about our next webinar. So I will stop sharing my screen now and pass the token to Dusan, who is going to give an overview of the I-BiDaaS project. Dusan, the floor is yours.
Thank you, Despina. My name is Dusan Jakovetic. I'm an assistant professor at University of Novi Sad, Serbia. And this is going to be a brief introduction to the I-BiDaaS project. So first, this is the identity card of the I-BiDaaS project. We are a project consortium of 13 partners with a total budget of about 5 million. We started in January 2018, which means that we are at about half a year until the project end. The full project name is Industrial-Driven Big Data as a Self-Service Solution, and it's a research and innovation type project, which means that we do both research, but also we try to bring this research somewhere closer to the market. And here you can see links to various media where you can reach us. So as I said, we are a consortium of 13 partners, and this is a well-balanced consortium between research institutes, universities, large and small industries. So in particular, we have FORT, which is the project coordinator, Barcelona Supercomputing Center, IBM Israel, CRF, which is a research center of Fiat, Software AG, CaixaBank, University of Manchester, Pons School, Atos from Spain, Aegis, which is an SME from UK, ITML, another SME from Greece, University of Novi Sad, and Telefonica Research from Spain. As several other BDV PPP projects, I-BiDaaS motivation is in European data economy, and we are doing research and innovation that tries to improve the European data economy. There are several challenges or barriers that we need to resolve in order to make a success. I'm going to focus on two key challenges that are of interest to I-BiDaaS. These are the lack of talent and the data silos. So by the lack of talent, we mean that the current big data technologies are so complex and diverse that several industries need to hire external experts in order to be able to fully harness the value from big data. Now, these services can be either very costly or simply there is not available talent on the market. For the second challenge, by data silos, we witnessed that there exist data silos both within a single company, within a single sector, or across multiple sectors that if broken successfully can again help us through improving the data economy. For the vision of the I-BiDaaS project, there are several important dimensions. I'm going to mention 3 of them, which kind of link to the previous challenges that I talked about. So the first one is that I-BiDaaS provides a big data as a self-service solution. And this solution kind of addresses the lack of talent challenge. So I-BiDaaS provides a solution where in-house domain experts in industries can more directly interact with big data technologies and in this way harness the value from big data. Another important dimension is that through several project activities and several technologies, I-BiDaaS is breaking data silos successfully. And finally, I-BiDaaS provides a complete and safe environment for methodological big data experimentation. In particular, I-BiDaaS focuses on 3 targeted sectors, which are telecom, banking, and manufacturing. And today, our main focus will be on telecom. With this vision of the I-BiDaaS project, I'm going now to basically read this slide to state what the I-BiDaaS project is about with a reference to what I said before. So I-BiDaaS aims to empower users to easily utilize and interact with big data technologies, and this is the self-service part, by designing, building, and demonstrating a unified framework that significantly increases the speed of data analysis while coping with the rate of data asset growth and facilitates cross-domain data flow. So this refers to breaking the silos towards a thriving data-driven EU economy. I-BiDaaS will be tangibly validated by 3 real-world industry-led experiments, and here we mean telecom, banking, and manufacturing. With this slide, just to say a couple of more words about the I-BiDaaS experimentation. So as I said, the 3 targeted domains are telecom, banking, and manufacturing. And this is also an opportunity to invite you to follow the subsequent webinar. We already had a webinar on banking, and we will have soon a webinar on the manufacturing sector. And the final slide for this introduction is meant to say that even though we focus in I-BiDaaS on the 3 targeted sectors, the results and technologies of the project can be applied also to other sectors as well. For example, energy or health. So now I would like to ask Ioannis to give us more details about the specific requirements in telecom industry for I-BiDaaS. Thank you.
Thank you, Dusan. Okay, can you see my presentation?
Yes, Ioannis.
All right, perfect. Okay, so Telefonica is one of the largest telecommunication companies in the world by market capitalization and number of customers. We provide over world-class fixed mobile and broadband networks, and we operate in 16 countries, which are split into 2 geographic regions, that of Europe and that of Latin America. We have approximately 356 million customers, including 270 million mobile customers, nearly 13 million fiber and cable customers, and more than 8 million pay TV customers. Now, our users interact with various services, which basically trigger the production of large and diverse types of data at different levels in our network infrastructure. More specifically, some data are produced at the user level by end user devices like smartphones and laptops, and include the data regarding their activities like web browsing, TV viewing, radio streaming, video calling, and so on. Other data are produced at the networking infrastructure level, that is by means of routers, antennas, and so on, as a reaction to the user activity in the network. That is by phone calls, SMS, other messaging services, roaming, traveling in the city, that is changing antennas, web browsing, and so on. But both types of data are extremely useful for modeling and understanding user behavior in an urban environment, and can be utilized by the telco that owns them or by other telcos and third-party companies. Now, given the volumes of aggregated data, there are several challenges that we have to deal with. First of all, the utility of the data generated across the network depends on how the data are aggregated across time, users, and locations involved. So depending on where and how the aggregation and modeling of such data happens, it can be extremely powerful for marketing and other purposes, like infrastructure planning, which is one of our use cases. But it can also raise great privacy concerns over the anonymity of the users that produce the data. For example, on one hand, browsing data of particular users can be very valuable for targeted advertising, but it can also be considered as privacy invasive. On the other hand, aggregated mobile data or mobility data of users in a city that are extracted from our antenna logs can be useful in deploying new infrastructure, services, or planning physical retail stores without violating the user's privacy due to the aggregation that takes place. And of course, the anonymization as well. Second, by sharing across companies, insights based on the user information and the activity. This information is regulated. These processes are all regulated, and they can be extremely difficult to achieve, hence diminishing the utility of the data and the insights that we can mine. Also, such sharing is not easy to audit and monitor, especially when it needs to be done at the user level or at least with the user's consent. We have strict EU regulations on user personal data put in place, like the GDPR and e-privacy. Therefore, novel methods need to be researched to detect and stop such activities that may threaten user cyber privacy. These challenges become even more difficult to address when the data are combined from different sources within a company, or taken to the extreme case, combined across companies. Therefore, in order for such diverse value data to be utilized in a secure, privacy-preserving, and industry-supported manner to create this EU data market, we need to investigate technologies like the ones we envision at I-BiDaaS to be able to deploy them in the near future. So coming to the I-BiDaaS platform, Telefonica, as a telecommunication company, we envisage to use many of the technologies that I-BiDaaS provides in a unified platform to solve some of the most important challenges that I discussed in the previous slide. To this end, I-BiDaaS can support the challenges faced by us by, for example, designing and implementing a complete framework of tools that augments real data platforms with the functionality needed to enable a new and highly diverse and synergistic data ecosystem in a privacy-preserving manner. Second, by leveraging advanced visualization approaches and dashboards that harness the power of multiple heterogeneous sources and big data analytics. This facilitates the ability to tweak the data, to be able to break it down, understand it, process it, extract value from it, and then visualize and communicate it, with the primary focus being empowering both an expert but also a non-expert big data practitioner. TID's, Telefónica's contribution to this vision is twofold. First, we provide three highly relevant and high-value use cases. Second, we contribute to the efforts of I-BiDaaS by making accessible to the consortium and thus breaking the data silos, both synthesized and real industrial data. To achieve all this, the data is the raw material that fuels the proposed research. But as I said, due to the sensitive nature of the real-life industrial data sets, as well as the substantial privacy and security risks involved in granting access to third parties, early access was anticipated to be highly challenging. Therefore, to facilitate the early exploration and development phase of the use cases where real data was not at the time available, we resorted to sharing metadata and data characteristics in order to synthesize data. So by realistic synthetic data, we refer to fabricated data that mimics the real data set of a data provider based on these metadata descriptors and other specification rules that we provide. However, it's not the real data. Therefore, there is no privacy. There are no privacy risks involved. Also, as a step towards the materialization of breaking the inter and intra-sectorial data silos and support data sharing and exchange, we also provide the consortium in-house access to specific data collections that are relevant and represent some of our use cases in a secure and controlled manner. So these data sets address 3 orthogonal use cases and consist of very diverse signals that span from call logs to streams of mobile phone transactions for many customers. And they are the product of joints of smaller collections that are curated and maintained by various product teams. So to this end, Telefonica met successfully both criteria of data diversity, data complexity, and cross-domain interoperability. And I believe the expected outcomes of this research is to integrate these, embed them into our products and improve specific KPIs that we have set and identified, and also motivate in the future or streamline a more secure data sharing both internally and externally, and develop tools that we can share and that they can support the highly dynamic and complex data analysis and empower both expert and non-experts big data practitioners. And now I would like to pass the torch to Dusan, who will present the big data architecture and I-BiDaaS solution and explain how we addressed these use case requirements.
Thank you, Ioannis. So I'm going to present the I-BiDaaS solution from the front end, sort of what it offers to end users. Then from the back end, what kind of technologies we are utilizing and developing and integrating in I-BiDaaS to make these functionalities to end users available. I will mention some key innovations of the I-BiDaaS project and also show how we solve concrete use cases provided by the Telefonica in the project. So what you see on this slide is a standard big data pipeline. So going from left to right, we have users that have certain data, they analyze their data, and then they can visualize or visualize data or share the results. But I'm going to focus here on some key aspects of the pipeline that we believe distinguish I-BiDaaS from other big data models. So on the side of the users, we provide 3 different modes of the platform: the expert, self-service, and co-develop, that are tied to different types of knowledge that the user has. So the expert mode is meant to expert big data developers that can upload their own code to the platform. The self-service mode is meant for users that have some data science and statistic knowledge so that they can select a predefined algorithm for a given domain problem. And finally, we have a co-develop mode, which is meant for industrial in-house employees that will develop their own application with the help of I-BiDaaS team. On the side of data, we have a technology for fabrication of realistic synthetic data provided by IBM that allows, for example, in early development stages, when there is not sufficient real data available, to be able to continue the developments. or this helps in situations where due to privacy concerns, the real data cannot be shared. On the side of analytics, the I-BiDaaS platform offers both batch and streaming analytics, and we will see later examples through concrete Telefonica use cases. And on the side of results, we can visualize results and share models. On this slide, what you can see is the I-BiDaaS platform from the backend, where you see a complex picture. I'm going to break it down according to the work packages of I-BiDaaS, explaining what kind of technologies we have in there. In this short format, it's not possible to explain how everything works, but we will see what we offer with respect to technologies. So on the side of data user interface and visualization, we have the TDF tool by IBM for fabricating realistic synthetic data. We have the Software AG's universal messaging, which is a message broker that makes the data available to other components in the platform. And we have the AG's advanced visualization toolkit that enables advanced visualizations. Work package 3 is responsible for batch analytics. There we have the COMPS programming model by Barcelona Supercomputing Center, which allows to develop algorithms that can be executed on parallel platforms. Within the project, University of Novi Sad and other partners are developing advanced machine learning algorithms in the COMPS programming model and applying them to the concrete industrial use cases, like, for example, the ones by Telefonica. We also have the Hecuba, which is a data management system by Barcelona Supercomputing Center, and the QBeast, which is a data indexing system. On the side of streaming analytics, we have the Software AG APAMA complex event processing engine and the Fort GPU accelerated analytics. And on the side of resource management and integration, we have the Atos resource management tools and the ITML integration services. Now I'm going to briefly describe the technological innovations within the I-BiDaaS project. So the first one is that we incorporate in the end-to-end big data solution data fabrication capabilities that I already mentioned before. Then we have the solution flexibility, where we mean the flexible solution with the 3 different modes of operation of the platform: the expert, self-service, and the co-develop mode. We have the easy-to-code programming paradigm that is that relies on the COMPS programming model, and we have the high code reusability, where basically we are able to develop a new machine learning model based on code templates by tweaking only a few lines of code. Further innovations are the synergy of complex event processing and GPU accelerated analytics for streaming. We have further the feedback from analytics to data fabrication and to problem modeling. And all of these technological advances have been demonstrated on multiple use cases across 3 different data providers and 3 different industrial domains. More information about our innovations can be found on our public deliverables website and other sources. I'm now going to focus a little bit more on the concrete use cases by Telefonica, provided by Telefonica, and the I-BiDaaS solution, highlighting the challenges from the perspective of data analytics, big data technologies that we needed to address, and also highlighted some achievements that, that we made. Ioannis is going to tell us more about these use cases. I'm going just to briefly provide the context for each of the use cases. So in this use case, the antenna KPIs, the context is that telecom operators need information which sectors underperform at any given time in order to provide, for example, quality of service. And the question is, in this use case, can we predict with a sufficient accuracy which antennas will become the next hotspots? From the data analytics and big data technologies perspective, this was a highly challenging use case because, first of all, we had a very large numbers of antennas on the order of 40,000 and 16 KPIs per each hour during one day. The problem from the data analytics perspective, because an antenna can be a hotspot or not, is basically a classification problem. And the one that we needed to solve was a highly challenging one because we were dealing with a highly imbalanced data set. So just to illustrate, we have one class on the order of 0.012% of data that corresponds to this class. So the data set was highly imbalanced. And also we have a certain data leakage when we split the data for training and testing. So the most conventional splittings would not work in our case. Our approach was to develop state-of-the-art fast and accurate parallel classifiers utilizing several tools. In particular, we used also the COMPS programming model. And what we can achieve is the classifiers with very high accuracy that are highly efficient. So the results here show the accuracy that we can achieve. So you can see that these numbers that should be as close to 1 as possible show very good results. This slide shows from the integration perspective that the I-BiDaaS solution can be specialized to the antenna KPIs use case. It's important to mention that this use case works in a stream processing mode. And as you can see, we are incorporating several technologies from I-BiDaaS. For example, the Aegis advanced visualizations, universal messaging, the algorithms developed by University of Novi Sad, and so forth. Another use case that we have is the user mobility. So the context is that users travel around the city and possibly create congestions. And the idea is to predict when and where the congestions will appear. And in other words, the question is, can we predict the movements at scale? From the data analysis perspective, this was also a challenging problem because, again, we are facing with a high volume data set. But another particular challenge was that even though the data set is of high quality, we had lots of missing data. So in particular, on the order of 85% of data was missing. And for this, we employed a time series approach. So basically, we trained the time series for each of the antennas. And we had a very large number of antennas on the order of 100K. So we need a high parallelization of the process to make it efficient. So for this, we used the joblib library. And the results are that we can achieve a good accuracy. The average mean absolute error on top 1000 model was about 1.25, which is a decent number, though we think that it can also be improved. But also, due to high parallelization, we get a very high efficiency where we trained on the order of 100K time series within 3 hours. And again, we can see that the I-BiDaaS solution can be specialized to this use case as well, where now we are working the batch processing mode, and again, we are utilizing several I-BiDaaS technologies, like the advanced visualization by Aegis, universal messaging by Software AG, ITMLs, orchestration services, etc. And the final use case is the use case on the call centers, where the context is that we want to improve the operation of the call centers, and in particular, we want to shorten the call duration and waiting time in call centers. There are several data analytics challenges that we need to face there. So for example, we need to provide real-time insights in a semantic sense by automatic information retrievals from speech interactions in phone calls. This corresponds to processing of large amount of natural language data, and all of this has to be done in a streaming analytics fashion. So our approach to solve the problem was to apply a GPU-accelerated text matching, where we are matching the keywords in the incoming data stream. And in more detail, our solution offers different types of analytics, like, for example, the sentiment score, the word frequencies, and the most frequent word count. And this is all offered for different time intervals, like the last minute, last hour, last day, etc. In terms of performance, we can achieve a very high efficiency, where we are able to process on the order of 40,000 calls per second. And again, you can see how the I-BiDaaS solution from the integration perspective can be specialized to this use case as well. Again, we are dealing with the stream processing mode, and you can see that we are incorporating several I-BiDaaS technologies, like, for example, the GPU accelerated tools from Fort, tools from ITML, AGIS, Software AG, and so forth. So now, Ioannis is going to present in a step-by-step fashion the demos that we are providing for Telefonica, and also more details on the use cases. Thank you.
Thanks, Dusan. I think it's the other way around. First, I will go through the use cases and then show the demos. Well, side by side, I guess. Okay, I believe you guys can see my presentation.
Yes, Ioannis.
Okay, great. So we have three use cases basically that we are looking into. The first one is about the quality of service. So we're interested quality of service in call centers. So we are interested in improving the performance of audio calls processing by automatically predicting the customer satisfaction. Here at Telefonica, at the call centers, we receive tens of thousands of calls to report problems, to follow up on feedback, to inquire about products, and hence it's a high value problem. We need to understand how we can process these calls in a more efficient manner, and narrow down to those calls that are the most urgent and most important ones, so that we can address them timely. The second use case is about understanding how we can optimize the placement of telecommunication equipment. This would allow us to improve the routing and placement of equipment in an urban environment. So in this particular use case, we're trying to understand basically if our hardware, our antennas, our cell sites are overperforming or underperforming, and under which circumstances, so that we know we can inform a more strategic placement of new equipment, or move around the existing hardware. And finally, we have the accurate location prediction with high traffic and visibility. This use case is about understanding mobility patterns, how people move around the city, and under which kind of context, and try to and anticipate, predict timely future events where people move at scale. And that's important because when we have a very high concentration of mobile phone users in an area, and we don't have the infrastructure to support that, that can lead to various connectivity issues and problems. So now we'll, after this brief overview, I will go through its use case separately and give you a few more details about them. I will start with the quality of service in call centers. So some of the examples and questions that we usually ask is, okay, users are calling to solve a technical question or to get commercial feedback. What is the call about? How can we automate the response, or how can we identify the high priority calls? And there are several requirements here. First of all, we have the customer satisfaction index, which is a key parameter for many organizations that offer some kind of commercial service. And it's essential to reducing customer churn and increasing our revenues. So we need to really quickly get familiar and understand the customer's perspective and sentiment, and also shorten the number of calls, duration, and waiting time. So in other words, we want to detect the customer satisfaction and or dissatisfaction, if you may, and motivation based on the automatic transcripts of the calls. So we want to automate the process of analyzing the calls, and instead of relying solely on the human agents, we want to put in place the technology that will help us speed up this filtering. And some of the challenges that stem from this case is, first of all, how can we employ advanced machine learning techniques that involve automatic speech recognition, sentiment analysis, customer satisfaction index prediction, and so on, to understand the call intent and the sentiment. How can we apply streaming-based models for real-time script adaptation? And also, how can we anonymize the transcripts? The data that we have been using consists of a mixture of heterogeneous structured and unstructured data sources. For example, we used 20 hours of speech manually transcribed for this language, where the speech data were anonymized, both using automatic as well as manual supervision. After this data was anonymized, we analyzed also the importance of various acoustic features that we extracted from the customer agent's spoken interaction, in trying to predict, again, eventually the self-reported customer satisfaction, which is our ground truth. And there has been some ongoing research on that. I'm not going to bore you with the details, but we've been trying various deep learning and machine learning models, testing the importance of different kind of features, either linguistic features or acoustic features, and so on. And we tried also different kind of architecture, like convolutional neural nets, and we came out to the conclusion that usually a combination of the different categories of features is usually works better for us. So this use case has also very specific KPIs. Currently, there is no automated solution in place, which means that the audio calls are processed by human agents. And as you can understand, this is very costly and time-consuming solution. To be more precise, if we consider an average call duration of 8.6 minutes, a human agent following a work schedule of 40 hours per week, that is 160 hours per month, could help process up to 11K calls per year. And this manual process allows one agent to flag about 2,300 low customer satisfaction calls that require further and immediate attention and can lead to customer churn. Now, the I-BiDaaS platform, with a configuration of one CPU core, can process 12 times those many calls per hour, which means it can process about 100K calls per year. And this increases the detection of low customer satisfaction calls by human agents from 2,300 to 7,000, and that's 200% improvement. And a solution from processing the customer audio calls in an automatic and scalable manner can go a long way, increasing the number of low customer satisfaction calls detected and hence addressed timely. And now I'll go demonstrate the dashboard for this particular use case. Okay, so this dashboard map of Spain, and as an example, we have pinpointed 3 particular call centers in 3 different cities. We have one in Barcelona, one in Madrid, and one in Sevilla. And okay, now since I just started the demo, it just started processing the data, so it takes a bit of time until the data converge. So what we currently see at first glance is, okay, first of all, we identify right away the call centers where they are located, and we see also a summary of the percentage of calls that have been addressed successfully. Those are the positive ones, and non-successfully, those are the negative ones. Currently, we are witnessing a breakdown or which comes and goes. We can assume that this is due to the pandemic. People are facing a lot of connectivity issues with their internet. The network is overloaded. Everybody's online, Skyping and gaming and so on. And to the right-hand side, we see for the selected city, for Sevilla, a kind of like a word cloud, basically the top 10 keywords extracted from the transcripts, the anonymized transcripts, sorted by frequency. And we see what's happening in the last minute, last hour, and at some point we will also see the last 24 hours. Okay, I have to say that for the purpose of the demonstration, we're not using the real scripts. We're using some auxiliary synthetic scripts, so these words might not make sense. I don't think somebody would assassinate, for example, a human agent or threaten them to assassinate them unless they were particularly unhappy. But you can get a feeling that by looking at those keywords, we can get a sense right away of what are the emerging problems, or in the case that we are dealing very successfully with the problems, we might get a hint of what we are doing good, or how satisfied the customers are. And okay, now this is a geographic representation, and now we have this insights as to what are the top issues that emerge. But if we go below, you will also see another chart, which is, again, it's updated, it's real time, and it shows us the daily, on the right hand side, the daily positive average score and the hourly positive average score. And also we have a curve that it's updated per minute. So here we see the for the three different cities, the progression of the sentiment of the calls, how successfully they are performed. And again, this is another kind of representation. We see the temporal dimension, so this gives us another view to the problem. We can see how well the call center is doing over time. See if at particular hours the call center is not working well, and maybe this will allow us to narrow down to what is the cause of that. Okay, I will now go back to the presentation and move on to the next two use cases, which I decided to bundle up together because they are not the same, but they are somewhat similar. So the first use case, the second, use case is about accurate location prediction with high traffic and visibility, and then I will talk about the optimization of placement and telecommunication equipment. So what is the accurate location prediction? Well, basically it's about people traveling around the city and creating traffic congestions in the network. And we want to know where they will appear next, when, and if we can anticipate new events that will cause movements at scale. Like, for example, a concert by, I don't know, Shakira, or something that will happen, or Bruce Springsteen, and then all of a sudden you have 50,000 people moving to a small space like a football stadium, and then, nobody has a good connection. And some of the requirements are about, understanding how we can forecast immediately the next events, how we can improve the routing and placement of the equipment that's already in place, or to order new equipment to be used. And the main challenges we have to deal with here is, first of all, as Dusan explained, we need to interpolate missing events to recover possible event trajectories, minimize the processing time with respect to the growing data size, and also maintain a real-time delivery of results. Our data set with respect to this use case consists of anonymous traces collected from a large European cellular network by tens of millions of subscribers. And each such trace is a time series of mobile events. And these events contain some kind of encrypted user ID. It's like a hash key that, of course, does not identify the user. It's just a dummy number that we give to at least separate this data, a timestamp, and the location of the base station used to deliver the service to the user. And those mobile events are generated every time a mobile device activates or deactivates in a network. That is when the user switches on and off their phone, makes or receives a call or an SMS, moves from one location to another. So that means that's what we call a handover from one cell site to another. Switches from one radio frequency technology to another, like between 2G, 3G, and 4G. Requests data access, and so on. And in this particular case, we want to predict movements from one sector to the other. We want to estimate the delta in the percentage of connected users per sector X hours in advance. And our forecasting model can incorporate information about other sectors, current status and load, contextual data like the weather for their particular location, or some occurring events like holiday events or other. The requirements here for the next use case, which is about the optimization of equipment placement. We want to understand whether we can avoid deploying new antennas and use our existing infrastructure instead, or whether we can predict with accuracy which antennas will become the next hotspots, and what models we can deploy. Again, we need to minimize the processing time with respect to the data volume that we have to process, and maintain real-time delivery of results. So in other words, here we want to predict those cell sites with high traffic and congestion events in order to optimize the resource distribution. And some of the challenges that stem are we want to analyze streaming data in order to improve the routing and placement of telecommunication equipment. We want to study the spatiotemporal patterns and provide insights on the dynamics of the cell sites, and as well as consider deep learning models and see how they perform as a function of time, amount of historical data, and the prediction horizon. So how much ahead into the future we want to make a prediction, and see how that impacts the model's performance. So the data here that we are dealing with, that we're examining, are basically coming from different kind of feeds, 2G, 3G, 4G, 5G, separated, okay? And they provide various key performance indicators like the coverage monitoring, voice and data service metrics about its radio sector. And such KPIs are the key information to understand the network performance. And we generally group them into these 5 categories: coverage, accessibility, retainability, mobility, availability, and congestion. And the solution that I-BiDaaS puts in place here is basically we want to exploit this KPI information to predict if a sector is going to be a hotspot or not. And as the main objective of the predictions is interventions, and such interventions usually cannot be implemented on the hour by operators, so we aim for a daily resolution here. And we address the problem as a binary classification task. Hence, our target variable is a binary label that corresponds to the notion of being a hotspot at a certain day. And alternatively, we also explore a multi-class prediction scenario where we classify an antenna as underutilized or overutilized or working under normal conditions based on a predefined percentage threshold of usage. And now we'll conclude with a demo of these 2 use cases. I will start with the mobility data. Again, in this visualization, this dashboard, what we see, of course, it's a demonstration. We see the map of a city. You can guess which city this is. And we see how the antennas are laid down here. And we have also this explanation to the side, which indicates what its color means. So basically, those antennas highlighted with a gray, within a gray circle, are those that are performing on average. They're 1 times the mean of their they have received the mean of connected users. They usually do. Those that are marked with blue or light blue are at 0.5 of their mean connected users, or 0.25. That means those antennas are underperforming because they have fewer users connected than on average, than what they receive on average. And then we have those that are accepting 1.5 times the mean of connected users, or 1.75 times the number of users they have on average. So those are overperforming. And sorry, 1 second, I will move them up. And here we can also isolate those cases. We can isolate those cases by clicking this button and say highlight those antennas that are underperforming, and all of a sudden, identify those areas with antennas that are not utilized properly, or highlight those that are problematic. So we can identify those areas in the city, the zones that we may have to install additional antennas or show everything. And at the same time, also adjust the opacity to make them more transparent and more visible or less visible, in order to identify which zones are we looking at. And again, the legend here shows the results. And then we have different also kind of layers. We have a base map. Then we can also use OpenStreetMap, or introduce any kind of other map we want to. So this is quite a flexible tool, and it's highly intuitive. It does not require expert knowledge. And I will proceed to the mobility use case. Sorry, the antenna KPI. The previous one was the mobility. Again, here we have now. Here we are dealing with historical data, so this is not real time. No, sorry, this is real time. This is a live view, and so we see here whether an antenna will become a hotspot or not. Those marked with red are hotspots. Those that are within regular usage are marked with gray. And this is like a live feed, and we are witnessing what happens in the city of Madrid as it moves on. And if we want to identify those cases that are problematic, that are overworking, and the hardware is not meeting the demands of the users, then we can just show only the hotspots and draw insights with respect to the zones of the city and the areas. Then we also have the option to see what happened in the past, like 1 hour ago, or 2 hours ago, or 3 hours ago, or 4 hours ago. Because in some cases, as I said, there are major events taking place, like a concert, like a protest, and therefore these are temporal events. These are not constant across time. And then this way we can identify that this is not a permanent issue. It's something that happened because of an accidental high concentration of users in a specific area. Or proceed again to the live streaming and see what's happening in the city. Okay, and with that, I think I can conclude my presentation and pass the torch back to Dusan.
Thank you, Ioannis. Thank you, Dusan, for your very interesting presentations. I think we have concluded with the demonstration, so it's about time to open the floor for questions. Before that, in the chat panel, you will find a link. We have created a questionnaire. It will take you only a few minutes, and your feedback is very, very valuable for us. And the other thing that we would like to, before going to the questions, is to say a few things about our next webinar. And I would like to give the floor to Marik. Marik, can you say something about the next webinar?
Yes, of course. So the 5th webinar will be taking place on the 2nd of July, so that's next week at 2 CEST. The topic will be Policy Cloud Policies Against Radicalization. So as said earlier, Policy Cloud will realize the European Cloud for Data-Driven Policy Management. It will provide the integrated and reusable models and analytical tools, and that way we will turn raw data into valuable and actionable knowledge towards efficient policy making. So in the next slide, there are some of the webinar takeaways that we will provide you with. So the Policy Cloud services will be used to transform the raw data into actionable knowledge, as said earlier. So this is very useful for policy creators. So this is practical information, also practical. This is a practical value for them. And then the Policy Cloud adopts the data skipping and the seamless analytical technologies that were already developed in the more mature BigDataStack project, because as you know, as we said earlier, the Policy Cloud project has started in January this year. So we are taking the technologies developed in the more mature project of BigDataStack one level further and implement them into the solution for policy makers. The analytical tools such as sentiment analysis and the opinion mining software will be applied to Twitter data to identify radicalization efforts and link those efforts to particular terrorist groups or attacks. So how the analytics will also be used is to segment radicalization efforts. So demographically, visualize radicalization trends and to assign risk profiles to individual suspects. So how analysis activities will respect the privacy requirements established will also be reflected within the ethics framework, and we'll also touch briefly upon that. Yeah, we would like to invite you to join us on the 2nd of July at 2 CEST for the Policy Cloud Policies Against Radicalization pilot webinar. Thank you, Despina.
Thank you, Marik. Don't miss this webinar. It looks very interesting. Okay. So let's now go to the questions and answer. I already saw that Ioannis replied, but maybe it would be nice also to read the question. Do you create separate machine learning models per language, or do you have a global model that can process and learn from data in all languages? I think this is referred to the call center use case. So Ioannis, maybe you can say a few things.
Yeah, although this is not my area of domain of expertise, but from what I understand is that these models are language agnostic in the sense that they can be trained and deployed in any kind of language, provided that we have the training data or the data in general. And maybe to some extent, we could also do some kind of transfer learning. Probably not with respect to the linguistic features, but maybe with respect to the acoustic features, because those are there are commonalities between languages in terms of how we speak and how we emphasize words phonetically and stress out certain syllables and phonemes, and what those mean. Emotion, what those express in the dimension of emotion effectively.
So this question was from Haris Sfirakis. I don't know, Harry, if you want to raise your hand and we can give the floor for if you want to further discuss. In the meanwhile, we do have another question. Is there already a process in place for new antennas location? For example, for how to deploy new antennas? Is it similar to what you demonstrated? Ioannis, I think you can take this one also.
Yeah, sorry, can you repeat the question, please?
Yes, or you can open the
Right,
Q&A. Yeah. Is there already a process in place for new antennas location? For example, for how to deploy new antennas? Is it similar to what you demonstrated?
So this is an ongoing work. I mean, so we don't have any process in place, at least as far as I know. But this is a tool that we are researching in the context of I-BiDaaS, and we want to also push internally. So we are showcasing these technologies, and hopefully this will present themselves as solutions to these problems, and will be adopted and implemented. But it's one thing to develop a tool; it's another thing for the technology to be adopted and put in place. That doesn't happen overnight. And you know, we're just finishing I-BiDaaS. We are on the 3rd year now. The technologies are now kind of maturing, but they are still these are still in a way proof of concepts. They are not fully tested, fully deployable solutions. So it takes some, you know, interaction and convincing to get there. But yeah, that's the eventual goal.
Great. Thank you, Ioannis. And one
Seems
question
that
for...
I get all the questions, the tough questions.
And one question from me. Can you please tell us your story regarding data sharing and data availability from the point that you started when you came to the project? And are there any lessons learned to share with today's attendees?
Yeah, don't participate in calls about big data and data silos and data sharing. Well, okay. The true story is that it was a bit of an odyssey. So in the beginning, you take the first step and you're not sure where you will land, whether you will find your way back to the Ithaca. So you have to go through a lot of adventures and deal with a lot of monsters. Some of them are called audit offices and legal councils. Others are called GDPR, and it has 7 heads, and whenever you cut one, 2 more pop out, and all that stuff. It is an interesting journey, and it's an inevitable journey, because if we want to eventually find a balance between, you know, safeguarding the privacy and the privacy of the user's data, but at the same time providing them with meaningful services and you know, making things work better for everybody, we have to find the silver lining somewhere. You know, we have to work things out. So yeah, the challenges are that you cannot, you present a project proposal and in 3 years you're telling people that you're going to take a big jump and end up somewhere. The reality is that you cannot run, you just take one step at a time. But that in itself is not a bad thing, because when you take one step at a time, you're more aware of where you're stepping at, and you do so in a speed that will, it's less likely that you will, you know, end up in a fall. Okay, so you orient yourself better, and you feel the grounds, and you're more confident about where you're walking on and what kind of soil you're walking on. And I think that's kind of the I-BiDaaS story. It was like this ambitious project that started with a big roar, got everybody's attention, and then it went silent for a while. And now it's kind of like emerging from the cave, and it's delivering what it promised, but in a way that people did not anticipate it. They were expecting these fireworks, but we came up with the solutions in a kind of like more like a silent force, you know? So I think that's the story, if I can put it in a more creative words.
Thank you, Yannis. So at this point, I don't see any other questions. Maybe you want to say a few things about the upcoming hackathon that Telefonica is organizing?
Was that planned that I would address all questions, or? Okay. The hackathon is part of the journey to Ithaca. It's something we didn't expect it will materialize, and we are still very doubtful about it, if I can be honest. And the reason for that is because of the high uncertainty with the pandemic, the situation with the pandemic. Currently, our intention is that we will see what's going to happen in July after people go on holidays, if this thing will blow up again or not. And then somewhere early August or mid-August, we will start preparing and advertising. And we have two scenarios in mind. One is if things go well and we are not under a new lockdown, we will push for a physical hackathon. But most likely, because of the travel restrictions that will still be in effect, and I think we might get a second wave in September. It's the most likely scenario. We will have the possibility of a virtual hackathon, which is kind of like trending these days, doing everything online like this webinar. In any case, we'll do our best to facilitate the hackathon. We have a really interesting data to work on. We want to, deploy we want to see what kind of solutions people will conceive, will create. Maybe people will get more creative, even more creative than us, and we might be positively surprised. But I think it's going to be an interesting event, and hopefully this can be a physical event, so we can see each other and meet each other and enjoy the whole process. If not, if not, we'll stick with what we have, because when life gives you lemons, you shouldn't try to create an orange juice,
I do hope for a physical one, though. Let's see. So,
any other questions for me?
No, I think we're done. I would like to thank you, Yannis, for being here today with us, for your very interesting presentation. I would like to thank Dusan for the technical presentation and what is behind the I-BiDaaS solution. I would also like to thank Marik for being here with us. We do have more webinars, so stay tuned. I would like to thank you all for being here today with us. Have a nice afternoon and take care.
Bye-bye. Thank you. Thank you, everybody, for joining and for helping out.
Thank you. Bye.